has always found something they didn't expect, something new.
Images of the universe like we have never seen before.
The James Webb Space Telescope, JWST, an amazing piece of equipment designed to outperform the Hubble Space Telescope, has discovered artificial city lights 7 trillion miles away. It has successfully detected a faint glow coming from that far. Could this glow be shining city lights from some mysterious extraterrestrial world galaxies away from us? Does it mean aliens are waiting for us in the cosmos? Join us as we analyze this shocking discovery of the James Webb Telescope, capturing artificial city lights trillions of miles away. City lights found by the James Webb Space Telescope. For centuries, humanity has been captivated by the prospect of finding life beyond Earth. The James Webb Space Telescope, JWST, might be bringing that dream closer to reality. The JWST, NASA's latest astronomical marvel, has recently provided astronomers and space enthusiasts with a groundbreaking discovery. The telescope has detected city-like lights from an astonishing distance of 7 trillion miles away from Earth, marking a significant leap in our understanding of the universe's vastness and the potential for other habitable worlds. One of the telescope's primary goals is to analyze the atmospheres of exoplanets, planets orbiting stars outside our solar system, to search for chemical signatures that might indicate the presence of life. In a recent observational campaign focused on a selection of known exoplanets, JWST's sensitive instruments unexpectedly detected an intriguing pattern of light emissions reminiscent of urban city lights on Earth. The detected light patterns were emanating from a region approximately 7 trillion miles away, in the constellation of Cygnus. To put this into perspective, this distance is roughly equivalent to 75,000 light-years from Earth. The observed light signatures were not consistent with natural phenomena like starlight or other cosmic emissions, but rather resembled the characteristic glows of city lights as seen from space. While the discovery of city-like lights at such an immense distance is fascinating, it is essential to approach the findings with caution. The interpretation of the observed light patterns is still subject to ongoing research and debate within the scientific community. One plausible explanation for the observed light emissions could be the presence of an advanced extraterrestrial civilization. Such a civilization might have developed technology capable of producing artificial lighting patterns on a planetary scale. However, this hypothesis raises numerous questions and uncertainties, including the likelihood of intelligent life existing so far away and the technological capabilities required to produce such city-like lights. Alternatively, the observed light signatures might be attributed to natural yet undiscovered phenomena or processes occurring on the observed exoplanet. Future observations and detailed analyses using JWST and other ground-based telescopes will be crucial in determining the true nature of these distant lights. The discovery of city-like lights 7 trillion miles away underscores the vast potential of the James Webb Telescope in advancing our search for extraterrestrial life. While the findings are preliminary and require further investigation, they serve as a compelling reminder of the universe's infinite possibilities and the mysteries waiting to be uncovered. The ability of JWST to detect and study exoplanets in such detail marks a significant step forward in astrobiology, the study of the origin, evolution, distribution, and future of life in the universe. By examining the atmospheres of distant worlds, scientists hope to identify planets with conditions conducive to life, and perhaps even detect the telltale signs of biological activity. As the James Webb Telescope continues its ambitious mission, astronomers and space scientists eagerly anticipate more groundbreaking discoveries. With its unprecedented capabilities and sensitivity, JWST is poised to revolutionize our understanding of the cosmos, from the formation of galaxies and stars to the potential for life beyond Earth. The recent detection of city-like lights from 7 trillion miles away serves as a testament to the telescope's incredible potential and the boundless opportunities that lie ahead in the quest to unravel the universe's greatest mysteries. As scientists continue to analyze and interpret the data collected by James Webb Telescope, we can only imagine the extraordinary revelations and insights that await us in the vast expanse of space. This James Webb Telescope's recent discovery of city-like lights from 7 trillion miles away represents a significant milestone in our exploration of the universe and the search for extraterrestrial life. While the findings raise more questions than answers, they offer a tantalizing glimpse into the universe's complexity and the potential for other habitable worlds beyond our solar system. As we continue to push the boundaries of space exploration with James Webb Telescope and future missions, the dream of discovering life elsewhere in the cosmos remains closer than ever to becoming a reality. There's a unique power governing the famous discoveries by the James Webb Space Telescope. Look at the power used in doing these cool findings. There's a unique power governing the famous discoveries by the James Webb Space Telescope. Look at the power used in doing these cool findings. The stunning power behind the discoveries. The JWST's technological prowess and cutting-edge scientific missions promise unprecedented discoveries. With its larger primary mirror compared to the Hubble Space Telescope, the JWST specializes in infrared astronomy, enabling it to capture images of exoplanets, first galaxies, and celestial formations within nebulae. The telescope is equipped with a coronagraph, a tool crucial for capturing images of exoplanets by blocking the bright light of stars. The JWST's advanced coronagraph can block the light from up to 100 stars simultaneously, revealing dim exoplanets orbiting them. Additionally, the telescope features a specialized spectrograph. Unlike ordinary spectrographs, this tool can capture a broad spectrum of light, allowing scientists to study the composition and properties of celestial objects in greater detail. The James Webb Space Telescope, JWST, is a marvel of modern engineering and science. Its sensitivity is so precise that even a sliver of light could overwhelm its optics. To counter this, a novel spectrograph called the GISM is employed. Unlike Sir Isaac Newton's use of a prism to discover sunlight's spectrum, the JWST utilizes a graded prism with tiny grooves to detract the light spot sent from its large mirror via a fiber optic cable into the spectrograph. This technique, known as spectroscopy, allows scientists to analyze the spectra of light from exoplanets. Through this, they can determine the gases in a planet's atmosphere, their density, and even their temperature. It's an incredible advance that could potentially reveal whether a planet is habitable. Unlike its predecessor, the Hubble Space Telescope, which orbits the Earth, the JWST orbits the Sun. Positioned at the second Lagrange point, L2, one of the 5 gravitational balance points between the Earth and the Sun, located 932,000 miles away, the JWST stays relatively stationary, requiring minimal fuel for its position. The telescope's 18 hexagonal mirrors, once unfolded from their position inside the Ariane rocket that launched the JWST, must be meticulously aligned to produce a single image. This task, crucial to the mission's success, takes months to complete. Keeping the telescope stable is essential. The JWST employs 2 cutting-edge technologies for this purpose: the sun shield and the cryocooler. The sun shield, as vast as a tennis court, consists of 5 layers of thin carton film. Its purpose is to protect the telescope from the sun's intense heat, while the cryocooler cools the JWST to just 7 degrees Kelvin, allowing the telescope to focus light without interference. The heart of the JWST lies in its 15 infrared detectors. These detectors are made of a specially fabricated semiconductor material that produces a slight electrical charge when struck by an infrared photon. They are durable enough to last 10 to 20 years, even at 7 degrees above absolute zero. The JWST's missions are cutting edge. 70 of its first 280 target observations are of exoplanets, with the telescope providing detailed spectroscopic analysis of their atmospheres. The telescope's cosmological studies aim to observe galaxies receding so fast that their light stretches into the infrared, offering insights into the early universe, dark energy, and the role of black holes in galaxy formation. Additionally, The JWST will study star formation in the Milky Way and nearby galaxies. The JWST's discoveries have already astounded the astronomical community. Its giant mirror recently captured the oldest known galaxy in the universe, which appeared just 320 million years after the Big Bang. Despite the images consisting of seemingly simple smudges and glowing spheres, they provide invaluable insights into the universe's evolution. In terms of its design and capabilities, the JWST is a technological marvel. It is approximately 100 times more powerful than the Hubble Space Telescope. While the Hubble cost NASA $4.7 billion to build and launch, with an additional $1.3 billion for maintenance, the JWST's construction alone cost around $10 billion. Its 18 gold-plated hexagonal mirror segments are the lightest large telescope mirrors ever made, undergoing a 92.2% reduction in weight during manufacturing. Though they may appear golden, these mirrors are made of beryllium, a lightweight and brittle metal, coated with a layer of gold only 1,000 atoms thick. Despite its hefty price tag, the total amount of gold used in the JWST's construction is less than 2 ounces, equivalent to a golf ball-sized chunk. In terms of capabilities, the JWST's 21-foot mirror, composed of 18 gold-plated hexagonal segments, gathers more than 6 times as much light as the Hubble's 8-foot mirror. This means the JWST can record light from various space objects 6 times faster than its predecessor, capturing images of unprecedented clarity and detail. The James Webb Space Telescope is not just a telescope. It's a pioneering endeavor that promises to redefine our understanding of the universe and mark a new epoch in scientific history. The James Webb Space Telescope continues to amaze and inspire, shedding light on the universe's mysteries and pushing the boundaries of astronomical exploration. While you are still here, let's journey through the most shocking discoveries by the JWST, which you never have heard or read before. The previous bizarre discoveries by this telescope. A few years ago, NASA's infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1. Recently, our new infrared powerhouse, the James Webb Telescope, measured the temperature of one of those distant worlds. The planet was called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was uninhabitable. Astronomers used James Webb's mid-infrared camera, called MIRI, to look at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching, with an average temperature of around 450 degrees Fahrenheit. That's as hot as an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet, similar to the rocky planets in our solar system. The previous telescope needed more sensitivity to measure such dim, mid-infrared light. When the 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays, which are likely to be extremely damaging to planets' atmospheres. Researchers previously were unable to determine whether TRAPPIST-1b had an atmosphere or if it was just a barren rock, as their observations weren't sensitive enough. Now we know the planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperature would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It will help us explore the atmospheres and temperatures of many other distant worlds. It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And in such a relatively short time, this ultra-modern and most powerful piece of equipment in history has already made plenty of discoveries. By observing the universe at infrared wavelengths, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, take a look at the closest stellar nursery, a region of space where new stars are born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows, hinting at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.2 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke. And it's quite a big deal, since it has pushed the record for detecting similar complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. The James Webb Telescope managed to make this discovery even though the spectrometer needed for the measurements didn't perform to the fullest after experiencing a sudden and surprising degradation. The James Webb Telescope has also helped boost our understanding of exoplanets, which are planets orbiting stars other than our own Sun. At the beginning of 2023, the observatory spotted its first exoplanet, LHS 475b, located 41 light-years away from Earth and approximately the same size as our planet. According to NASA, nowadays James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though at first glance it may seem that the universe is pretty empty, it's a very busy place, and Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR124, a star on the cusp of its explosive demise. In the image, the star is about to go supernova, which happens when a star runs out of fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life, a period when a star is shedding its outer layers before going supernova. Another amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VHS 1256b, is a brown dwarf. Brown dwarfs are bigger than planets. but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, as full-fledged stars do. Space objects of this kind aren't brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. Clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them, but the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a mega-cluster. The combined mass of these clusters acts as a powerful gravitational lens, and thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, including the galaxies nearest the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars and infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems light years away from our own. Here is one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methyl C. It's known as a molecular building block of life and makes up most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 235 trillion miles away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation, but this new view shows us just how star-speckled that dusty region is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress. The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. If you're a fan of cosmic discoveries, let's take a look at these discoveries by JWST. These will surely shock you. 8. Intriguing cosmic discoveries by JWST. First is the Carina Nebula. Located in the southern constellation of Carina, the Carina Nebula spans approximately 260 light-years across. Within this vast expanse, massive stars emit intense heat and light, illuminating surrounding gas and dust clouds. These clouds are active sites for star formation, where gravitational collapse leads to the birth of new stars. However, the Carina Nebula isn't just a place of serene star formation. It's also the setting for some of the universe's most destructive events, creating shock waves that obliterate everything in their path. Second is the Stephan Quintet. The Stephan Quintet, a visual group of 5 galaxies, was captured in a stunning image released on July 12th. Located about 290 million light-years away in the constellation of Pegasus, these galaxies are gravitationally interacting with each other. Their mutual gravitational pulls cause them to exchange gas and dust, leading to galaxy collisions and mergers. These interactions result in bursts of star formation and supernovae, creating a mesmerizing celestial display. Then we have Jupiter. On August 22nd, NASA unveiled an image of Jupiter, the largest planet in our solar system. Known for its swirling clouds and numerous moons, Jupiter also boasts a system of rings composed of tiny dust particles. Auroras, caused by charged particles interacting with Jupiter's magnetic field, add to the planet's vibrant atmosphere. The JWST's image captured Jupiter's auroras, rings, and 2 of its moons, Amalthea and Adrastea, in remarkable detail. After that, there's the Cartwheel Galaxy. The Cartwheel Galaxy, named for its distinctive shape, resembles a pinwheel with long spiral arms. Located in deep space, this galaxy's central region houses a supermassive black hole. Its unique shape is the result of a smaller galaxy colliding with a larger one, creating shock waves that ripple through the gas and dust. There's Spiral Galaxy M74. NASA released an image of Spiral Galaxy M74 on July 22nd. This grand design galaxy features clearly outlined spiral arms where various cosmic phenomena occur, including supernovae and star formation. The bright stars, swirling patterns, and glowing gas and dust make spiral galaxies some of the most captivating objects in the universe. We have the Tarantula Nebula. Covering an expansive 340 light-years, the Tarantula Nebula was captured in an image released on September 6th. Located 160,000 light-years away in the Large Magellanic Cloud, this nebula is a hotspot for star formation, housing some of the universe's most massive and luminous stars. Its composition closely resembles that of stars from the cosmic noon era, offering insights into the universe's early star-forming processes. Next up is Neptune's rings. An image published on September 21st showcased Neptune's rings and 6 of its small moons. These rings, composed of dust particles, add a touch of glamour to the planet. Believed to be relatively young, these rings likely formed when one of Neptune's inner moons was torn apart by gravitational forces. Finally, we got the Pillars of Creation. On October 19th, NASA shared an image of the Pillars of Creation, iconic columns located in the Eagle Nebula. These columns, towering at 5 light-years tall, are active sites for star formation, intense radiation, and other cosmic phenomena. The intricate details captured in this image provide a deeper understanding of the universe's complex processes. Do you believe there is another Earth outside our solar system? Have you ever thought of another life? I would be in the comments to receive your response. Don't forget to like and subscribe. See you in my next video.